Welcome to Math 95. The following Zoom session, I can't talk. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. Okay. So today we're going to go on and take a look at section 7.3. But before we do, we have some questions from 7.1 and 7.2. So let's start with 7.1. This is problem number 10. It says, find all real numbers for which the rational expression is undefined. Enter your answers as a comma-separated list. If no values make the expression undefined, enter none. All right, and the expression is the following. It says 2x minus 17 over x squared minus 25. So when would this thing be undefined? It would be undefined when the denominator is 0. So what we're going to do is we're going to take the denominator and set it equal to 0, solve it. That will give us the values that make the denominator 0. Those are the values that we're looking for. Okay. So x squared minus 25 equals 0. The left side of the equation is the difference of two squares. So factoring it, I get x plus 5 times x minus 5 is 0. Take each factor that contains a variable, set it equal to 0, and then solve each of these first degree equations. So x is negative 5. And then over here, add 5 to both sides. X is 5. So what values of x make this thing undefined? When x is negative 5 and 5. So either one of those put in here makes the denominator 0. Dividing by 0 is undefined. Any questions about that particular problem? All right, we're going to take a look at number 15 from 7.1 as well. This says, simplify, assume that the denominator is not 0. And we have the following. 8 times the quantity t minus 1 plus 8, all divided by 8t plus 8. All right. We can't cross out these 8s or those 8s because they are not factors of the entire numerator or the entire denominator. Okay. So what we've got to do, let's take the numerator and let's distribute. We get 8t minus 8 and then plus 8 over 8t plus 8. Combining like terms, we get 8t over 8t plus 8. Now, I still can't cross out this with this because this 8t is not a factor of the entire denominator. So what I've got to do is factor out an 8. Okay. Now, this 8 in the numerator and this 8 in the denominator are factors of the entire numerator and the entire denominator respectively. Those reduce down to 1 over 1, and we have t over t plus 1. But wait, are we finished? What about these two? Nope, can't reduce those out because this t is not a factor of the entire denominator. So basically, that is my final answer. Any questions about that particular problem? Okay, give me just a minute here to find, let's see here. Now we're going to look at some from section 7.2. Let's see here. And We want 7.2, number 11. Okay. It says multiply and then simplify if possible. All right. P squared minus P minus 6 over 2P minus 6 times 5P squared minus 14P minus 3 over P squared minus 3P. So what I'm going to do is factor each piece. Okay. So let's see here. This one would be P and a P. The product is -6. The sum is -1. So how about a -3 and a +2? That would give us a -1P in the middle and a -6 at the end. Okay. Then this one, we're going to take out the greatest common factor, which is a 2, leaving behind P minus 3. Okay, let's see here. I'm going to do this one next, taking out the greatest common factor, which is a P, and I have a P minus 3 left over. Okay. And I saved this one for last because that's the one that's going to take the most work. So I've got 5P squared minus 14P minus 3. So A is 5, B is -14, and C is -3. The product is -15, the sum is -14, so -15 and 1. So 5P squared minus 15P plus 1P minus 3. Factoring by grouping, greatest common factor, 5P, the leftovers P minus 3, the leftovers P minus 3 with a +1 outside. So P minus 3, 5P plus 1. So P minus 3, 5P plus 1. Any questions on all of that? So again, I did the easier ones first just to get them out of the way. So now I can go in and reduce. Let's see here. P minus 3 over P minus 3 is 1 over 1. P minus 3 over P minus 3 is 1 over 1. And that looks to be all I can get rid of. So my numerator is P plus 2 times, 5P plus 1 all over 2 times P. And again, you could multiply the numerator out if you wanted to, or you could just leave it factored like I did. Okay, same section. We're going to look at problem number 19. But before we go on, any questions about this problem? Okay, so this is 7.2, number 19. It says divide and then simplify if possible. So my original problem is x squared minus 19x over 5x plus 5 divided by the quantity x minus 19 squared over 25x plus 25. The first thing I'm going to do before I factor anything is to change this division problem into multiplying by the reciprocal. So I get x squared minus 19x over 5x plus 5 times 25x plus 25 over x minus 19, the quantity squared. So now we'll go through and factor each piece. This one, x squared minus 19x, I can factor out a greatest common factor of an x and have an x minus 19 left over. Okay. This one, I can take out the greatest common factor of a 5 and have x plus 1 left over. This one, I can take out the greatest common factor, which is a 25, and have x plus 1 left over. And finally, this one is really already factored. It's what? X minus 19 times x minus 19. Two factors, two identical factors. So now we're ready to reduce out common factors. Well, I can take this x minus 19 with one of these x minus 19s. I can take this x plus 1 with that x plus 1. Oh, 25 over 5 is 5 over 1. So in the numerator, I've got x times 5 times 1, or 5x. In the denominator, I've got 1 times x minus 19, or just x minus 19. So there's the final answer with that problem. Okay, let's see here. Number 29. We good to go on to the next example? All right, 7.2, number 29. Perform the operation and simplify if possible. So we have b squared minus 9b plus 14 all over b squared minus 10b plus 16 divided by b squared plus 2b over b squared minus 6b minus 16. So we're dividing. The first thing I'm going to do is change division of a fraction to multiplication of its reciprocal. So b squared minus 9b plus 14 over b squared minus 10b plus 16 times b squared minus 6b minus 16 over b squared plus 2b. So we'll factor this one. That's going to give me a b and a b and a minus 7 and a minus 2. Product is 14, sum is negative 9. Okay. And then this one is going to be a b and a b, minus 8 minus 2. Product is negative or positive 16, sum is negative 10. And then this one, which is b, and minus 8 plus 2. That's going to give us a negative 6b in the middle and negative 16 at the end. B squared plus 2b, take out the greatest common factor of b and have a b plus 2 left over. So now we've factored everything. So now I'm going to go back and reduce out common factors. Let's see. I can get rid of a b minus 8 on the top and the bottom, a b plus 2 on the top and the bottom, a b minus 2 on the top of the bottom, and I'm left with b minus 7 over b. And that is that one. We good to go on or still writing? Good, okay. This is 7.2, number 30. Very similar to number 29 that we just did. Perform the operation and simplify if possible. 5x squared plus 41x minus 36 over x plus 9 divided by 5x squared minus 49x plus 36 all over x minus 4. So first thing I'm going to do is change division to multiplication of the reciprocal. So I get 5x squared plus 41x minus 36 over x plus 9 times x minus 4 over 5x squared minus 49x plus 36. Okay, well, the x plus 9 and the x minus 4, those aren't going to factor any further. I'm going to run out of room here, so I'm going to take this trinomial And I'm going to go to the next page, recopy it, and factor it. Okay, so 5x squared plus 41x minus 36. Okay, it's a trinomial. It's in standard form. Let's see, there's no greatest common factor. It's not a perfect square. It doesn't have a leading coefficient of a 1. So I'm going to use grouping. A is 5, B is 41, C is negative 36. Let's see, the sum is 41. Negative 36 times 5 would be what? Negative 180, is that right? Negative 36 times 5 is negative 180. Okay. So my product is negative, my sum is positive. So the bigger number has to be positive. So let's try 180 and negative 1. That would give me 179. 90 and negative 2 would give me 88. 45 and negative 4 would give me, bingo, 45 and negative 4. So 5x squared plus 45x minus 4x minus 36. Factoring by grouping, greatest common factor 5x, leftovers x plus 9, leftovers x plus 9, minus 4 outside, x plus 9, 5x minus 4. Any questions on what I just did there? Now I'm going to take that and put it back on the previous page. X plus 9. So x plus 9, 5x minus 4. All right. And now we're going to deal with this one. 5x squared minus 49x plus 36. 5x squared minus 49x plus 36. Is that correct? Minus 49 plus 36. Yes. Okay. So trinomial, standard form, no greatest common factor, not a perfect square, leading coefficient, not a 1. So I'm going to use grouping. A is 5, B is negative 49, C is 36, product is positive 180, sum is negative 49. Okay. So now the bigger number has to be negative. So how about negative 180 and 1? Or a negative 1? That would be what? Negative 181, negative 90 and negative 2, that would be negative 92, negative 45 and negative 4, that would be negative 49. There's our two numbers. 5x squared minus 45x minus 4x plus 36. Factoring by grouping. Take out a 5x, leaving an x minus 9, and a minus 4, x minus 9, 5x minus 4. So that's going to go back up there. X minus 9, 5x minus 4. X minus 9, 5x minus 4. So now we're ready to reduce this thing down. Well, let's see here. We could reduce those down to 1 over 1, and those down to 1 over 1, and we're left with x minus 4 over x minus 9. A lot of work for that problem, huh? Yeah. One more. 7.2, number 31. This says perform the operation and simplify if possible, but it's multiplication to start with. So we have 9x squared minus 12xy plus 4y squared over x cubed y squared times x cubed y over 9x squared minus 4y squared. Okay. Well, we're going to leave this alone, and we're going to leave that alone for now. That is a trinomial in standard form. No greatest common factor. It looks like it could be a perfect square. So let's see if it is. 3x, 2y. 3x, 2y. And let's see, let's get rid of that little dot there. And this would have to be a minus and a minus. Yep, that works. Excellent. And then let's take a look at that one. Difference of two squares. 3x plus 2y, 3x minus 2y. Okay, so one of those and one of those reduces to 1 over 1. X cubed over x cubed reduces to 1 over 1. Y over y squared is 1 over y. So in the numerator, I have 3x minus 2y. In the denominator, I have y times 3x plus 2y. And that's all the questions that people asked of me today. So now we're going to go on to 7.3, the new stuff. Okay. Let's go back to arithmetic for a moment. If we are adding or subtracting two fractions with the same denominator, we add or subtract the numerators over the common denominator. In this case, we can take it down further to reduce it to 1/2. Okay, so if we're adding or subtracting two fractions with the same denominator, we add or subtract the numerators over the common denominator. So with that in mind, let's add or subtract some rational expressions, some algebraic fractions with the same denominator. So 4 divided by s plus 4 divided by s would be 8 over s. Any questions about that? All right. 7/10 plus 3y over 10 would be 3y plus 7 all over 10. Okay, how about this one? B cubed minus 8 over 10b to the 4th power plus 8 over 10b to the 4th power. That is b cubed minus 8 plus 8 over 10b to the 4th power. Adding the numerators, combining like terms, we get b cubed over 10b to the 4th power. But now we can reduce that down. B cubed over b to the 4th is b to the -1 over 10, which would be 1 over 10b to the +1, or just 1 over 10b. Because recall, if you have a base to a negative exponent, you move it on the other side of the fraction bar and it changes the sign of the exponent. We okay with that? Anything there I need to go into more detail? Okay, let's see if we can write that a little clearer. That's 10b, 1 over 10b. Okay, let's see here. What about this one? Y plus 2 over 10z plus y plus 4 over 10z. So we're adding two rational expressions with the same denominator. So we're going to add the numerators over the common denominator. Combining like terms in the numerator, I get 2y plus 6 over 10z. But now I can factor a 2 out of both terms in the numerator and reduce 2 over 10 to 1 over 5. And I'm left with y plus 3 over 5z. Okay, let's see here. How about this one? 1 divided by h squared minus 4h minus 5 plus h over h squared minus 4h minus 5. So this would be h plus 1 over h squared minus 4h minus 5. However, I can factor the denominator into, let's see, 1 times negative 5 is negative 5, and 1 plus negative 5 is negative 4. Okay, so now I can come back and reduce this to 1 over 1. So I have 1 over h minus 5. Right. How about this one? 8x minus 7 over x plus 3 plus 2x plus 37 over x plus 3. Well, that would be 8x minus 7 plus 2x plus 37 over x plus 3. Combining like terms, 10x plus 30 over x plus 3. Factoring the numerator, taking out a 10, x plus 3, x plus 3. Reducing out the common factors, final answer, 10. That worked out nicely. Okay. Well, addition is great. Subtraction, we have to be really careful. And we'll get to what I'm talking about here eventually. Let's start out with something basic. 2x over 25 minus x over 25 would be 2x minus x over 25, which is x over 25. (16c over 11 minus 4c over 11 would be 12c over 11. C plus 7 over 4c to the fourth minus 3 over 4c to the fourth is c plus 7 minus 3 over 4c to the fourth is c plus 4 over 4c to the fourth. So far, so good. How about this one? T over t squared plus t minus 2 minus 1 over t squared plus t minus 2. So that would be t minus 1 over t squared plus t minus 2. But we could factor the denominator into that and reduce those down to 1 over t plus 2. Still not too bad. How about this one? Y plus 8 over 2y times y minus 14 minus y over 2y times y minus 14. So that's y plus 8 minus y over 2y times y minus 14. Combining like terms, the y's would cancel, and we have 8 over 2y times y minus 14. But I could reduce the 8 and the 2 to 4 over 1. So now I've got 4 over y times y minus 14. Okay. Not too bad. Let's see how you do on this one. 3y minus 2 over 2y plus 6 minus the quantity 2y minus 5 over 2y plus 6. Take a minute and work that one out. Let's see what you get. We pause briefly for station identification. This is your Mariner network or something like that. Now, if you do this correctly, the answer should be 1/2. Let's take a look at it and let me tell you, if you got it wrong, what you probably did. Okay, so I'm going to subtract the numerators over the common denominator. So I'm going to get 3y minus 2 minus 2y minus 5 over 2y plus 6, which then would be y minus 7 over 2y plus 6. Well, how in the world did I come up with 1/2? Well, there's something wrong with what I did. Right here, that needs to be grouped because you're subtracting that entire quantity. Okay, now in all these previous examples, we were only subtracting a single term, so it didn't become obvious. But here I'm subtracting that whole quantity 2y minus 5. So what's that going to do? We're going to have 3y minus 2 minus 2y minus is plus 5 over 2y plus 6. Okay with that? So combining like terms, I'm going to get y plus 3 over 2y plus 6, which is y plus 3 over 2 times y plus 3, which is 1/2 because the y plus 3 is reduced out. So you got to be careful with subtraction because you're subtracting that whole thing. So you've got to distribute the subtraction sign to each term inside the group. Okay. Common mistake that students make. Be careful that you don't make common mistakes. Make the uncommon mistakes if you're going to. Okay. All right. Let's take a look at this one. Let's see here. 8a squared over 2a plus 5 minus the quantity 4a squared plus 25 over 2a plus 5. So this gives me 8a squared minus the quantity 4a squared plus 25 over 2a plus 5. So here's that same situation. You've got to subtract each term in this numerator. So we get 8a squared minus 4a squared minus 25 over 2a plus 5, which is 4a squared minus 25 over 2a plus 5. But now the numerator is the difference of two squares. And then these common factors reduce out. And my final answer, 2a minus 5. So be careful when you're subtracting that you subtract the entire quantity. Okay, new topic. So we've been adding or subtracting fractions with the same denominator. But what if they don't have the same denominator? Then we have to find the least common denominator. We need to build each fraction until it has that new common denominator, and then we can do what we've been doing, add or subtract the numerators over the common denominator. So what I want to look at right now is how to find the least common denominator, okay? And let's go back to arithmetic. Let's say I've got 3/4 plus 5/8. Some of them are fairly obvious, with arithmetic, it's like, oh, the greatest common or the least common denominator of 4 and 8 is 8. So the LCD is 8. So then you'd go through and you'd say, well, this isn't going to change. Here we're going to multiply by 2 over 2. So 3/4 becomes 6/8. 6/8 plus 5/8 is 11/8. Okay, because it's fairly easy to look at that one and say, oh, the LCD is 8. What if it's not so obvious? What if we've got, let's see, 3/10 plus 7/15 15ths, okay? And maybe this one's obvious to you. Maybe it's like, oh, I can tell it's 30. That's great. But I want to look at a way to look at it that will help us when we're dealing with polynomial denominators. What we're going to do is we're going to factor each denominator, okay? So 10 is 2 times 5. 15 is 3 times 5. The least common denominator is the product of the highest power of each prime factor within all of the denominators. So the LCD is 2 times 3 times 5, or 30. Now, let's look at a different example. Let's say we've got 20, 17 20ths, and then 3 25ths. Okay, so 20 is 2 times 2 times 5, and 25 is 5 times 5. Okay, so I've got 2 squared times 5 and 5 squared. Those are my denominators. The least common denominator is the product of the highest power of each different prime factor within each different denominator. So I need 2 squared times 5 squared, because 5 squared is the highest power of 5, and 2 squared is the highest power of 2. So this is what? 4 times 25, which is 100. So the LCD of 20 and 25 is 100. And that one might be a little harder to just look at and figure out rather than doing this. So we're going to break things down into factors, take the product of the highest power of each prime. Okay, let's apply that to algebra. It says, find the LCD of each pair of rational expressions. 4 over 9y, 11 over 3y. Okay, so if we factor 9y, we get 3 times 3 times y, or 3 squared times y. If we factor 3y, we get 3 times y. Okay, so the least common denominator would be the product of the highest power of each prime factor. So we've got 3 squared times y, or 9y. So 9y is the least common denominator of 9y and of 3y. Okay, so far? All right. 27 over c cubed d, 17 over 2c squared d cubed. So c cubed times d, 2 times c squared times d cubed, the LCD. I've got a 2, I've got c's, and I've got d's. The least common denominator is the product of the highest power of each different prime factor. So I need a 2, I need c cubed, and I need d cubed. So 2c cubed d cubed would be the LCD, the smallest number that this and this both go into evenly. You okay with that? Right? How about this one? D squared minus 5 over d plus 9, and d minus 3 over d. Well, the prime factorization of d plus 9 is just d plus 9, and the prime factorization of d is just d. So what's the LCD? Now, here's where people make the mistake of saying, oh, it's d plus 9. No, it's not. This d is a prime factor. This d is not a factor at all. Okay, it's not a factor of the entire denominator. The factor is d plus 9. So what you need is actually d times d plus 9. You need this times that, because even though this has a d in it, it's not a factor. The d itself is not a factor. Do you see that? That's the tricky stuff. Okay, so your LCD is going to be d times d plus 9. Okay, now let's see here. B plus 1 over 5b minus 10, and then b over 6b minus 12. So my LCD, well, I'm going to take 5b minus 10 and factor it into 5 times b minus 2. I'm going to take 6b minus 12 and factor it into 6 times b minus 2, but that's actually 2 times 3 times b minus 2. Okay. So what are my prime factors? I've got a 2, a 3, a 5, and a b minus 2. The highest power of each of them is just to the first degree. So 2 times 3 times 5 times b minus 2, 30 times b minus 2. And you can leave it that way, or you could write 30b minus 60 if you wanted to. Okay. How about this one? 5m plus 6 over 4m plus 12, and then 7 over 6m. 4m plus 12 is 4 times m plus 3, which is 2 times 2 times m plus 3, or 2 squared times m plus 3. 6m is 2 times 3 times m. Okay, so my LCD, the highest power of 2 is 2 squared. The highest power of 3 is just 3. The highest power of m is just 1m. And the highest power of m plus 3 is 1m plus 3. So again, this m is a factor. This m is not. The whole thing is a factor. So my LCD is what? 4 times 3, 12m times m plus 3. Question there. Okay. Now, the next set of directions are perhaps a little confusing, so let me clarify them. It says, build each rational expression into an equivalent expression with the given denominator. And it has 4 over y, and then a semicolon and 7y. You may have encountered something like this in a pre-algebra class, and it might have looked something like this. Basically, it's the same thing. They're saying, take this rational expression, rewrite it as a new fraction with this denominator. So 4 over y equals what over 7y? Okay, now, what do I have to multiply by y to get 7y? By 7. But if I multiply the denominator of a fraction by a number, I have to multiply the numerator by the same number. So 4 over y equals 28 over 7y. That's the answer that they're looking for. All right with that? Okay. How about this one? 7 over 6c, 30c squared. So 7 over 6c equals what over 30c squared? So what do I need to multiply by 6c to turn it into 30c squared? 5c, right? So I need 5c on top, which is 35c. So there's the new fraction. Now, don't make the mistake of saying, oh, well, I need to reduce that. Right now, we're building. We're not reducing, okay? There's a time to build. There's a time to reduce. This is the time to build. Well, lumber is expensive, right? Okay. Let's see here. Build each rational expression into an equivalent expression with a given denominator. Same directions. So we've got x plus 7 over 3x minus 15. And we want our denominator to be 3 times x minus 5x plus 10. Okay, so Notice what I did. I took this and I factored it. So now, how do I get from here to here? What am I missing? Oh, I'm missing a factor of x plus 10. So my new numerator has to be x plus 10 times x plus 7, which is going to be x squared plus 7x plus 10x plus 70. So I'm going to get x squared plus 17x plus 70 over 3 times x minus 5 times x plus 10. Okay, but I had to factor this out so I could see what was missing and what I needed. Or same thing, what's missing, therefore what I need. Okay, let's see here. How are we doing for time? We got 4 minutes. Let's go back and do one of the previous examples. I've got b over b squared minus 4 minus 2 over b squared minus 4. So this is b minus 2 over b squared minus 4, which is b minus 2 over b plus 2 times b minus 2. These do not cancel, they reduce. There's still a 1 in the numerator. A common mistake, students will cross these out and say, oh, it's just b plus 2. No, it's not. It's 1 over b plus 2. Okay. Let's see here. Here's a look-alike. We've got part A is t over 12 plus 5t over 12. Part B is t over 12 times 5t over 12. And part C, that's what Moses did, t over 12 divided by 5t over 12. So to add two fractions, if they have the same denominator, we add the numerators, t plus 5t over the common denominator, 6t over 12, which would reduce down to t over 2. Okay, multiplying, we'd multiply straight across. There's nothing that I can pre-reduce here, so I'm going to get 5t squared over 144. Dividing, I'm going to change it to multiplication of the reciprocal. Now the 12s reduce and the t's reduce, and I have what? 1/5. So I've got 3 entirely different answers depending on the operation. Okay. All right, so that's it for today, section 7.3. I'll be back at 1:15 with an office hour should you have need of me. Otherwise, have a great day, and I will stop the recording